So this recording is for students who need extra practice finding limits and functional values from looking at graphs. Okay, so the first one, limit as x approaches -8. Okay, so what we have to remember, and I think this is what usually messes students up, every answer here will be a y value. Okay, every answer here will be a y value. Again, if they exist. Okay, so limits are always the y value. We go to this value of x, -8. Now, when it crosses the x-axis, the functional value is 0. Okay, so I actually have the point f of -8 is 0. Okay, so this is an x-intercept. The limit is also 0. Okay, and by this point, we have probably learned that if the function is continuous at a point, the limit and the functional value are the same. Okay, so next I go to -6. Okay, and I encourage you at every point, pause the video for a second, you try to get the answer, and then hit play again to check your work with me. Okay. Now, -6 is at x equals -6. It's one of those weird cases where I have a point here down at -3, but then I have actually, I think I drew this backwards. I'm sorry. This should be an open circle. This should be closed. This should be open. Sorry. Let me make a note here. Open circle. All right, so this is one of those weird cases where I have an open circle and then a functional value somewhere else. So when I stand close to -6, and that's why I like to draw my little people. Like, here's my little people. They have no idea that anything crazy happens at -6, because they don't step on -6. Okay, they just stand really close to -6. And they see functional values really close to -3. However, if I step right on -6, the circle is colored in at -2. Okay, so this is one of those places where limit as x approaches c of f of x does not equal f of c. Okay, up above, we had a place where the limit as x approaches c of f of x equals f of c, and that's part of our definition of discontinuity. Okay, so then we move on to -3. Okay, so here we have a jump discontinuity. The open circle's up here at 4. So again, I stand on the x-axis, I stand just to the left of -3. Okay, so I encourage you to pause the video and try this one before I just give you the answer. Okay, but I'm standing just to the left of -3. I see functional values getting close to 1. All right, I have no idea anything there's going to be any problem. And actually, if my little person steps on -3, that's where the closed circle is. So f of -3, which is over here, f of -3 is also 1. Okay, but if I were on the right side of 3, right, and I'm looking up at these functional values, and just because there's a hole there, remember, a limit still exists when there's a hole, because the hole just means get close to, okay, rather than equaling, right? And that's what the limit means, just get close to it. So from the right-hand side, I would say 4, and when the limit does not equal the functional value, right, which is happening, well, actually, no, the limit doesn't exist, right, because these two things don't match. Right, so when the limit doesn't exist, then my function is discontinuous. Okay, so my right and left hand limits have to match for the limit to exist. okay? So next, coming to 0, x equals 0, okay? Look up. I see the point, let's see, that's 8 there, so that's 7 up there. And again, limit equaling functional value. Okay, I am continuous at this point. All right, you pause the video for a minute and try the next couple. Okay, try to get to those with the video paused. Okay, and at x approaches 2, nothing interesting, right? I would just get the functional value 5, right? So the limit is 5, f of 2 is 5. Okay, my function is continuous there because the limit equals the functional value. Okay, at positive 3, right? The negative's behind it, so this is positive 3. If I stand at the left, I see functional values close to 4. If I stand on the other side, I see functional values close to 3. And when my left and right hand don't match, it's the DNE for the limit. We always see this situation in a jump discontinuity, where the left-hand limit exists, the right-hand limit exists, but then the functional value, let's see, the functional value here is the 3, because that was where the circle was filled in. So the functional value exists and the left and right-hand limits exist, but are different. That's how we know we have a jump discontinuity. Okay, so moving on to 6. Again, why don't you pause the video and try to get these last 3 done. All right, when x approaches 6, there's just an open circle there at 5. Okay, so a hole in the graph. Functional value DNE, but limit does exist, right? So this is how we know we have our hole in the graph. Okay, when the functional value does not exist, but the limit does. All right, and then looking at 9, well, let's see, if I'm 9 from the left, I stand my little guys right here. I look up at the y value, and the y value is 3. The y value on the right is down here. All right, so the y value at the right, I actually have to look down. That surprised me for a second, but that would be -1. Again, left and right don't match, so DNE on the limit. But f of 9, so that open circle is at 3. Okay, so f of 9 is 3, or the closed circle, I'm sorry. Closed circle is the functional value. Okay, and then finally at 10, over at 10, we have that open circle down there at, gosh, it's almost hard to tell, -3. Okay, so this limit is -3. But the functional value, oh, am I too far down? Functional value is DNE, which again, that's our hole in the graph. Now, let me just contrast what we just did with this question. Okay, a limit and a functional value, we're finding y values. Okay, what if I gave you this question? When does f of x equal 6? All right, we were doing this as practice at the beginning when we were talking about the difference between x's and y's. So this time I actually gave you the y, right? Find the x's for which f of x equals 6. Okay, so this is where And actually this, because this goes up, it would happen again too, but let's just focus in on this piece in the center. This is where I come over here and I draw a horizontal line at 6, right? And then I say, okay, what are the X values? Looks like about -1.5. And let's see, on this side, looks like about +1.5. Okay, so I don't want you to mix up the difference between finding Y values or being given a Y value and finding the X value. Okay, because limits are all about finding Y's. Okay, but on a quiz or a test, I'm sure I'm going to ask you at least once, right, to be given a Y value, find me the X that gives me that as output. Okay, so be prepared for that type of question too. So again, thank you for watching.